Hello, math students. Welcome back to our module on statistics and probability. This is lesson 8, and it is called Sampling Variability and the Effect of Sample Size. Our goal for today we will learn about sampling variability, learn what sampling variability is, and how it can be affected by sample size. The question that I want you to think about while we're working with this is, how does the sample size affect sampling variability? All right, in our Things to Know section, we're going to discuss what sample variability is. Sample variability is the result from taking samples means from the same population and comparing them to each other on a dot plot. An example of sample variability would be last week when we were working with your rectangle sizes, your rectangular areas of those random rectangles, and how we came together on the board and we listed all of your individual means on the same dot plot. That's what sample variability is. So sample variability is the result from taking sample means from the same population and comparing them to each other on a dot plot. You will want the sampling variability of the sample mean to be small so that you can expect your value of the sample mean to be close to the population mean. So basically what we want to do is all of the dots on the dot plot, when you want it to be an accurate measure, they need to be clumped together so that they're not spread far, far away. So when you're looking at sampling variability, if this was our dot plot right here, and it really doesn't matter what the numbers are because I'm just trying to show you a picture, but what we would want is we want our data points to not be too spread out so that we have a whole bunch of different plots on there. We want them to be rather close to being the same so that you can see that there's very little variability in your dots. So you want the sampling variability of the sample mean to be small so that you can expect the value of the sample mean to be close to the population mean. So we want the sample mean to be close to the population mean. The size of the sampling variability is determined by the sample size used to gather the data. So if you have 32 kids in a class and everybody has a different sampling mean that we're going to put on the dot plot, then the size of the sampling variability is determined by the sample size used. So our size, if we had 32, is kind of big as opposed to only having 5. So you can hear the difference between those two sizes. If the sample size is small, only a few data points, then you could get a sample that contains many large values, which makes the sample mean large, or you could get a sample that contains many small values, which makes the sample small, which is where it gets a little bit skewed, because if your sample size is too small, you won't get a genuine representation of all the data points. If you use a large sample, it is more likely to have the values that are equally spread along the large and smalls, and any extreme values are averaged out with the other values to produce a more central value of the sample mean. So basically what this is saying is you want a large sample so that it can produce a more central value for the sample mean. Because if you have a central value of your sample mean, that means that your actual sample mean is more real or more consistent with the data points you're using. So the most important thing to remember about the effects of sample size that has on sampling variability is a larger sample is preferable, because then the sample mean has a smaller sampling variability, which means that the sample mean is likely to be closer to the true value of the population mean, because that's what we're trying to get. And ultimately, when you're all done, you want your sample mean to be closer to the true value of the population mean, because what you're trying to do is you're trying to use your sample to represent all of the people that will be in that population, or all of the things that will be in that population, than it would be for a smaller sample. So your sample wants to be kind of large, and the reason why we want it to be large is because those extreme values can be absorbed into the mean itself. And then once you're able to take your mean and everybody else's means and put them on a dot plot, then you will be able to look at the variability, and you want your variability to be low variability so that they're clumped together. Because if they're clumped together, then this sample mean will be closer to the population mean. Okay, so sample variability is basically when you are looking at some data, you find the mean of that data, and then you post your mean on a community dot plot. Everybody else posts their mean on that same community dot plot, and then you look for how spread out your means as a class are. And you don't want them to be widely spread, because if they are widely spread, then you're further away from the population mean. So you want them actually to be clumped closer together so we have low variability, because then that means those sample means that we have are better representing the population mean, so the group as a whole. And then the size of the sampling variability is determined by the sample size, and you want the size to be large in your sample, because a large sample is a more central value of the sample mean, which means that it will be closer to the true value of the population mean. Okay, now I know that's a lot of talking and not a lot of doing, but when we do our practice problems in class, you're going to see how this makes more sense. The thing that I want you to take away from today's notes is today we will learn sampling variability, which we've talked about 2 times now. You find your mean of your data set, put it on a dot plot along with everybody else's means of their data sets, and then you compare them. That's your sample variability. Then you decide from that sample variability whether they are high variability or low variability, and you want it to be low variability, because if you have low variability, that means you have very little differences, and those very little differences will mean that your sample mean is a true representation of the population mean, which is good. And then the other important thing to remember about this lesson was your sample size. You want your sample size to be large enough that it can represent everyone involved, because with the larger sample, you'll get those extreme values averaged into the whole thing, and it will have a more central value of the sample mean. And remember, you want your sample mean to be close to the true value of the population mean, like we set up here. Okay? So going back to our question, how does the sample size affect the sampling variability? I would say that the sample size greatly affects the sampling variability, because if you have too small of a sample size, then you won't get a true picture of what your population is. Whereas if you have a large sample size, then it will be able to truly represent them, and then you can figure out what your variability would be. You want your variability to be low, not high. All right, kiddos, that's all I have for you today in this lesson. Talk to you soon. Bye.